Good morning. I just got a pineapple at the grocery store, and it's a really big pineapple. In fact, it's so big, I don't really know how heavy it is. It looks pretty heavy. I'm going to take it inside, put it on my kitchen scale, and find out how heavy it is. I've got my kitchen scale here, and now I'm just going to stick the pineapple right on top. There we go. And it says it is 65.6 ounces. What? 65.6? I thought decimals had to be less than 1, but this decimal is more than 1. There's a 65 on the left, and there's a 0.6 on the right. I don't even know how to think about that. Is there something similar that reminds me of things that have parts and wholes? Oh yeah, mixed fractions. But this isn't a mixed fraction, it's like a mixed decimal or something. I wonder if there's a way that I can think of mixed decimals as mixed fractions. Let's find out. So far, we've been looking at the paintings of Vincent van Gogh, and we've been looking at them in terms of decimals and fractions. When we had a whole painting, we would call it one whole, but we would also break it into parts. For example, we knew that an entire row across, or an entire row up and down, would be 1/10. And we also know that if we broke that 1/10 up into just one piece, that one piece would be 1/100th. So the rows or columns would be 1/10, and then a single piece would be 1/100th. What does that remind you of? It reminds me of hundreds blocks, tens blocks, and ones blocks. So imagine we could represent decimals as hundreds blocks, tens blocks, and ones blocks. We can imagine the hundreds block over here as a whole number, and then these lines over here as tenths, and then the individual pieces as hundredths. Just like we were doing with the painting, except now I've broken them up into pieces. In that case, what would this number be? Well, there would be two wholes, 1, 2, and then there would be a decimal bit. And the decimal bit would be 1, 2, 3, 4 tenths and 3/100ths. So 2.43. 2 wholes, 4 tenths, 3/100ths, 2.43. Or 2 and 43/100ths, just like when we were making mixed fractions. So what's the trick here? The trick is we count the tenths and put them in the tenths place. We count the hundredths and put them in the hundredths place. And that's how you write your decimal. Or you can write it as a mixed fraction like we did before, counting the parts that are not wholes and then putting them over 100 because we're dealing with hundredths. I'm going to let you give it a try. Here are 3 different representations of mixed decimals. One on the top left, one on the top right, and one on the bottom. Remember to count the whole hundredth grids as one whole, and then these as tenths, and then the individual pieces as hundredths. So what I want you to do is represent that as a decimal and as a mixed fraction. Press pause to try it out, press play to check your answers. Welcome back, let's check your answers. In the top left we have 2 wholes, and then what's the fraction bit or the decimal bit? 1/10 and 4/100ths. So 14/100ths, so 2 and 14/100ths. And you can write that as a fraction, or you can write 2.14. In the top right, we've got 1 whole and 1, 2, 3, 4, 5 tenths and 9/100ths. 1, 5, 9. So you could write it as 1 and 59/100ths or 1.59. And in the bottom, we have 3 wholes, 1, 2, 3, 1/10, 1, and 2/100ths, 2. So 3, 1, 2. And you could write that as 3 and 12/100ths or 3.12. Fantastic. Well done, everybody. Now I want you to try it the other way. I'm giving you 3 numbers that are mixed decimals. There are wholes and there are decimals that come after the whole. And what I want you to do is draw them as base 10 blocks. You don't need to draw each of the little grids in between. Just draw a large block for your wholes, a stick for the tenths, and a tiny square for the hundredths. So get a piece of paper and try that out. Draw each of these as base 10 blocks, and then check your answers after you press play again. Let's check your answers. Starting in the top left, 1.3. Well, that's just 1 whole and 3 tenths. In the top right, 2.08. That's just 2 wholes and 8 hundredths. And in the bottom, we've got 4.21. That is 4 wholes, 2 tenths, and 1 hundredth. Well done. Now let's go back to the way we were looking at paintings before. We didn't break them up into individual wholes, tenths, and hundredths. We just had a whole block, some of which was shaded in, and some of which wasn't shaded in. But it's the same thing. It's just that in this case, all the pieces are squished together. So we've got a whole, we've got tenths, and we've got hundredths. Well, how many wholes? We've got 1 whole. How many tenths? Remember, tenths are the sticks that go all the way across. We've got 6 tenths. And how many hundredths? 4. 1 whole, 6 tenths, 4 hundredths. We'd write that as 1.64. And how would we do the one on the bottom? Again, we count the wholes, and then we do the decimal part. How many wholes do we have? 1, 2, 3. 3 wholes. How many tenths do we have? 1, 2, 3. 3 tenths. And how many hundredths do we have? 1, 2, 3, 4, 5, 6, 7. So 3.37. I want you to try it yourself. I'm going to give you 2 of these shaded in pineapple grids, and what I want you to do is represent them as decimals. Remember that a whole shaded in pineapple grid is 1 whole. Press pause to try it out. Press play to check your answers. Okie dokie, let's check your answers. In the top one, we've got 1 whole, as you can see, and then we've got our parts. So 1 whole. Is this enough to be a tenth? No, it's not. It's less than a tenth. So we have 1 whole and 1, 2, 3, 4, 5, 6, 7 hundredths. 1 whole and 7 hundredths. Are there any tenths? No, there's not enough for there to be a tenth, which is why I put a 0 here in the tenths place. Not 1.7, that wouldn't be right. If it was 1.7, it would be 1 whole and 7 tenths. But this is 7 hundredths, so we need to make sure we put a 0 in the tenths place. What about on the bottom? How many wholes do we have? 1 whole, 2 wholes. So 2 point what? Well, it looks like we've got some tenths here. How many tenths? 1, 2, 3, 4. 4 tenths. And do we have any hundredths? No. So we're going to say 2.40, or you could just say 2.4. Now that I know how to represent mixed fractions as decimals using a picture, can I do it without a picture? Absolutely. Here's an example. The mixed fraction is 1 and 28 hundredths. Well, we know the whole is going to be 1, so I've already put it there. What about the fraction bit? We need to turn the fraction bit into a decimal bit. And to do that, we need to know how many decimal places we're going to be using. The denominator is 100, so we need to go into the hundredths. So this place is the tenths place, this place is the hundredths place. We need to go into the hundredths, so 28 goes into the hundredths place, 1.28. But what if the mixed fraction has tenths instead? Well, in that case, we just need to go into the tenths place. Again, I've already put the whole amount. We're just dealing with the decimal amount after the decimal point. The denominator is 10, which means we're going into the tenths. What's the tenths place? That's the tenths place. We're only stretching into the tenths place, so 1 and 7 tenths, 1.7. Okay, it's your turn to try it out. Here are 6 mixed fractions, either with a denominator of 100 or 10. And what you need to do is turn those into mixed decimals. Press pause to try it out. Press play to check your answers. All right, let's check your answers. In the top left, we have 1 and 95 hundredths. So we start with the 1, and it's going to be 1.95 going into the hundredths. Top middle, 2 and 9 tenths. And 2 and 9 tenths is the same as 2.9. 9 is in the tenths place. 9 is in the tenths place. In the top right, we have 2 and 4 hundredths. We know that's going to extend into the hundredths place. We need to put 4 in the hundredths place. So that's going to be 2.04. 4 needs to be in the hundredths place, not in the tenths place. That's why I put the 0 after the decimal point. In the bottom left, 3 and 8 tenths. So we need to write our 3, then the decimal point, then an 8. Because 8 is going to be in the tenths place. Why? Because the denominator is 10. So 8 will be in the tenths place. Bottom middle, 7 and 90 hundredths. 90 is going to extend into the hundredths place because that's the denominator. Okay, so it's going to be 7, decimal point, 90, 7.90. And finally, in the bottom right, we have 1 and 5 tenths. So we're going to have a 1, then a decimal point, and then 5 is going to be in the tenths place. Awesome. I knew you could do it. Now we need to figure out how to do it in the opposite direction. How do we turn mixed decimals into mixed fractions? Here's an example. 1.28 is our mixed decimal. And we know that the mixed fraction is going to start with 1 because that's our wholes, and the wholes are on the left side of the decimal point. Now we just need to deal with the fraction. Well, we know it's going to be 28, so 28. But 28 what? Look at the place value in the decimal. Tenths, hundredths. It goes into the hundredths, so the denominator is going to be 100. What if we have a decimal that doesn't go into the hundredths? How would we represent that? Here's 1.7. Well, we start with our whole, 1, 1, and now we deal with the fraction bit. We know that the numerator is going to be 7, so let's just put it. Now let's figure out the denominator. In this case, the decimal place goes into the tenths, so we need to put 10 as the denominator. Great. Now it's your turn. I want you to change these decimals into fractions. And of course, these are mixed decimals, so you need to turn them into mixed fractions. Press pause to try it out. Press play to check your answers. Answer checking time. Let's start on the top left. 3.18. We know it's going to be 3 wholes, and then the fraction bit is going to have a numerator of 18 and a denominator of 100. Why 100? Because 18 goes into the hundredths, tenths, hundredths. In the top middle, the whole amount is going to be 2, and then the fraction amount is going to be 3 with a denominator of 10, 3 tenths. Why? Because 3 is in the tenths place. Top right, 5.42. So 5 is going to be the whole amount, 42 is going to be the numerator, and the denominator is going to be 100. Why? Because 42 goes into the hundredths. Next one. Bottom left, 4.8. So the whole amount is going to be 4, the numerator is going to be 8, and the denominator is going to be 10 because 8 is in the tenths place. Bottom middle, 6.23. The whole amount is going to be 6. 23 is going to be the numerator, and the denominator is going to be 100 because 23 extends into the hundredths place. Tenths, hundredths. And finally, 9.1. Well, the whole amount is going to be 9. Then the fraction bit is going to be a numerator of 1 and a denominator of 10. Why? Because 1 is in the tenths place, so a denominator of 10. And now we know how to convert mixed decimals into mixed fractions, and mixed fractions into mixed decimals. Now let's see if I can solve my pineapple problem. Now that I know how to convert mixed decimals into mixed fractions, let's see how this one would work. I've got my 65 wholes over here, and my 6/10ths over here. And I know it's 6/10ths because it's a 6 in the tenths place. So I would write this as 65 and 6/10ths. Okay, so my pineapple is 65 and 6/10ths of an ounce. Well, now that you know how to convert mixed fractions into mixed decimals and vice versa, I want you to complete page 228 in your Jump Math book, and then complete the quiz that happens afterwards. And in the meantime, I'm going to try and figure out how to eat this pineapple, because it's quite hard on the outside, and I don't want to eat it the way it is. Enjoy your math. I'm going to try and figure out how to enjoy my pineapple.